Hello, everybody. It is very important that you feel comfortable with all of these sorts, so I'm going to show you how I implement them. This was our kind of rough and ready testing framework, and the reason to have a testing framework is you don't really know if your sorting algorithm works unless you test it against several different kinds of input. So we've got, this isn't a terribly long list. There are different ways that you could criticize this as covering all the cases. But this is kind of a normal length expected case, but notice that it's got a lot of repeated elements. We've got some ones that don't have repeated elements. We have some edge cases, so you want to ensure that your sorting algorithm works even if you give it a list with one element or a list with no elements. You should still be able to sort these. There's nothing really to be sorted. You would just return the list unchanged, but it shouldn't crash. So we're going to take all these lists, we're going to take all these arrays, and we're going to add them to a list of all our test cases, and then we'll loop over the test cases, and this is for debugging purposes. We'll print out what the test is and what it looks like before and what it looks like after. So let's dive right in with bubble sort here. We don't need to return anything because whatever modifications we make to the input are going to permanently change the array that we've passed because we pass a memory reference to that array. Let's remember what the pseudocode for bubble sort is. We want to do something like this. We want to traverse the array, swapping adjacent elements that are out of order. And we want to keep doing that while array is not sorted. This may not be what our eventual implementation looks like, but let's do our best to do that much. So for the moment, I'm going to create an infinite loop on purpose because I just want to focus on this traverse the array, swapping adjacent elements that are out of order. So I can traverse the array this way. I start at the beginning, and I go to the end. How do I check if adjacent elements are out of order? So I'll check if, oh, you know what, I want to rename, I don't like test, I like array. I'm going to rename this to array. Okay, so how do I test if adjacent elements are not in order? So I want to test the element at I, and I want to test the element that's to the right of that, I plus 1. If they were in order, I would expect this to be true. I'd expect that the element to the left is less than or equal to the element to the right. So this is what must be true if they're out of order. The element to the left is larger than the element to the right. So if they're out of order, let's swap them. And I'll write a helper method for swapping. So I'll give it the array, and I'll give it the two locations that I want to swap. Okay, what I want you to be noticing here is some of my process. So I imagine the entire solution all at once, and now I'm diving in to implement parts of the solution while leaving other parts unimplemented. I'm going to go ahead, and I'm also using helper methods wherever it seems convenient. So I'm going to implement swap now. I'm going to create the method swap. And I'm going to call the indices A and B. This was the warm-up the other day, and this is a very important thing to know how to do. So I'll create a temporary variable where I'll hold the element at A. Now I'll replace the element at A with the element at B. And now I'll replace the element at B with the original element at A, which I saved before I overwrote it. Cool, that's all that needs to happen, because remember when we pass the array, we're passing a memory reference, so I don't need to return anything. This is permanently editing the original array. All right, where are we? Great, so we're traversing and we're swapping. Okay, so how are we going to decide if we're done? Well, one thing we could do is we could count the number of swaps. So we could say if we've got, if we traverse the whole array and we never make any swaps, that must mean it's in order. So I could say keep going while number of swaps is greater than 0. And if number of swaps equals 0, then we'll be done. So actually, let's reset number of swaps to 0 inside there. And then whenever I make a swap, that's where I'll increment number of swaps. Okay, so that's one possible implementation of bubble sort. Let's give it a quick test. And it's gone wrong right away. Oh, it's gone wrong in this other thing. Hold on. Okay, it's gone wrong right away. So here is my first test case, and it immediately said index out of bounds 14. 14 is the location that's out of bounds. And I have a feeling that's the last, that's one after the last location in the list. It's happening right here. Oh, and I know why. I was intending to change this, but then I was talking and I forgot. So I'm looping over the whole list. I'm checking each element and the one to the right. So if I'm checking the one to the right, it's got to be the case that the element to the right is less than off the end. So I want to end one early. Okay, let's try it again. All right, do these look sorted? The answer is they do look sorted. Okay, so I will call that working. Let's do one more implementation of bubble sort, just to show you a different idea. Let's pretend this element right here was 100. Let's imagine what happens as we compare and swap adjacent elements. So I'll swap those two elements. Then I'll not swap these two because 100 is going to be larger. But then when I see these two, I'll swap them because 100 is larger. So now 100 ends up here. Then I'll end up swapping these two because 100 is on the left, so I'll swap 100 to the right. And hopefully you can see that 100 is always going to be the largest thing in the pair I'm looking at. And so 100 is always going to get swapped because it's always going to be bigger. And so if I traverse the array once, eventually I'm going to hit the largest element in the list, and then that one's going to get swapped over and over and over again until eventually it ends up in the last spot. That's why it's called bubble sort. It's because with every single traversal, the largest thing bubbles up to the last place in the array. So what that tells me is that each time I traverse, one element ends up where it's supposed to go. So if I had, let's say I had, let's make another test case. Let's pretend I had 4 elements, okay? And let's pretend they're in reverse sorted order. We'll call this one 6. If I had 4 elements, after the first traversal, 9 would be in place at the end of the list. After the second traversal, 8 would be in place at the second to last spot in the list. After the third traversal, 7 will be in its location. And if we have 9 and 8 and 7, 6 is automatically where it needs to go. So if I have a length 4 array, I really only need to traverse it 3 times. So let's use that idea inside bubble sort. Instead of having a do while, I'll have another for loop. I'll say for, I'll use n because that's the number of times I want to traverse. And I'll say I want to traverse array.length -1 times because I want to traverse however many elements there are -1. And then here, I'll put the traversal inside there, and I don't need number of swaps anymore. And this should also work if we run it. You might be thinking that this is a little bit wasteful because inside every single time we traverse, we go all the way to the end of the array. But I know that after the first traversal, I never need to visit the last element anymore because I've already put the largest thing there. And after the second traversal, I never need to visit the second to last element. So what that means is I can end early. I can say, I want to traverse the whole list, except I want to stop before whatever element. So on the first traversal, when n equals 0, I want to go all the way to the end. But when n equals 1, I want to end 1 early because I've already placed 1. And when n equals 2, I want to end 2 early. So that implies that I can just say I want to end n elements early, and then I'll be done. So this is a slightly more efficient version than the version I just wrote. Let's make sure it works. And then we'll move on to selection sort. Okay, this seems to have worked. Let's move on to selection sort. So, selection sort. I'm going to call it array. Let's remember the pseudocode for selection sort. The idea is for each location in my list, I want to find the largest value in that location or larger, or let's say so I'm going to find the largest value to the right of that location and then swap that largest value into the location. So let's imagine when I start, I'm at location 0, I'm at index 0. I'm going to find the largest value. I said to the right, but I should say at that location or right of it. So I'm going to find the largest value in the whole array, and then I'm going to swap that into the location. What is the location? It's location 0, because I'm in 0 in the loop here. So I'm going to find the largest thing in the loop and swap it into location 0. Then the next time through the loop, my index will be 1. And so I'm not going to look at location 0, because that's already got the largest thing. I'm going to find the largest value at index 1 or larger, and then I'm going to swap that into index 1. And then I'll look at the largest value in index 2 or larger, and swap that into index 2, and so on. So let's try and realize that. I'm going to call this one target location, and target location will go all the way to the end of the array. You might be thinking this is not quite as efficient as it could be, and you're right. I'm going to program by intention. So I want to know the location of the largest thing, and I'm going to call it find largest. I'm going to give it the array, and I'm going to tell it my starting location. So I always want to find the largest starting at some location searching to the right. And then once I've found it, I want to perform a swap in my array, and I'm going to swap the location of the largest with the target location. So that's it. That's my whole algorithm. If you're not practicing programming by intention like this, I think it's a great thing to practice. Okay, so I'm going to call this start location. So now I'm going to loop starting at the starting location and going to the end of the array. So here I'm starting at start location. I'm going to the end of the array. I'm trying to find the largest, so I'll have largest so far is integer.min value. And then location of the largest thing so far, I'm going to initialize to -1. And then I'll say if the array at the location I'm looking at is larger than the largest so far, I want to store two things. I want to save the largest thing so far as the new value I just looked at, and I want to save the location where it happened. And the reason why I want to save the location where it happened is because at the end of the day, I don't actually want to return the largest value. I want to return the location where the largest value happened, because that's the information I'll need in order to make my swap later on. Okay, so now I've found the location of the largest value. Oh, I'm not trying to find the largest. Excuse me. I'm trying to find the smallest. Well, let's do this version. So let's say I'm doing a version of selection sort where I'm starting at the end and I'm traversing to the beginning. Oops. So I'm going to swap the largest elements to the end rather than the smallest elements to the beginning. So now I'm going to find the largest, but I'm going to always be starting here going left. So start location greater than or equal to 0 going left. All right. What's happening? Oh. Okay, so this is a slightly different version of selection sort. My target locations are going to start at the end of the list. I'm going to find the largest thing to the left, and I'm going to swap that to the end of the list. And so this is finding the largest to the left, so I'm going to start at my starting location, but then I'm going to traverse left until I get to 0. And I'm keeping track of the largest thing I've seen so far. Okay, let's go ahead and run it. I'm using selection sort in my test. Here we go. Oops. Okay, it looks like I am successfully sorting. Great. Okay, for your homework, please don't just copy what I've done. Do it the other way. So instead of finding the largest, find the smallest and swap it into index 0 and then 1 and then so on. Okay, let's do insertion sort. Insertion sort is probably the trickiest of all of them. Okay, let's remember the pseudocode for insertion sort. I wish I had my document camera because it would really help to display the array and sort of show you step by step. Unfortunately, I don't. So the idea is, here's the idea of insertion sort. When you're sorting a list of numbers, we start at index 1, and we're assuming everything to the left of that index is already sorted, and that index to the right is not sorted. So when you start at index 1, the list of 9 is already sorted because any list that's length 1 is automatically sorted. Like, you can't have a not sorted thing that's length 1. Okay, so 9 is sorted, but now we're going to insert 8 into the sorted list on the left. And we got to insert it in the place that it should go. And so the way we're going to do it is we're going to copy that value that we're going to insert to a temporary variable. And then over and over again, we're going to ask, is that value smaller than each thing in order to the left? And as long as my value is smaller than the one to the left, I'm going to want to shift this value to the right. So what I'll do is I'll copy this value right, and then eventually, either I'm going to run out of things to shift, in which case I'll be out of bounds, or I'll hit a position where the thing I'm trying to insert is not actually smaller, and so I don't want to shift anymore. And then once that's happened, the value I'm trying to insert, I want to copy into the location that's right above the last thing that happened. Okay, if that seemed confusing with my just talking and sort of gesturing with the mouse, go back and watch one of the videos that actually shows the sort happening, and watch it until that idea makes sense to you. Or do it yourself. You could make your own list and do it yourself. So let's think. What are we trying to do? I am trying to loop through a bunch of locations. So I'm going to call this one I guess I'll just call it I. That's fine. Except I'm going to start at index 1. And I'm going to get value to insert is going to be array index I. And now I want to search to the left to find the place to insert. If you're thinking about programming by intention here, that would be a great idea. So yeah, actually, let's do it. So insert value at I. So in that case, we don't need this one yet. So over and over and over again, we're going to look at a value, and we're going to insert that value to its own left. And then we're done. Okay, that seems enough. Oh, sorry, I also need to pass the array. Okay, so now we'll have the value to insert. And now we'll have a while loop where we're going to search left. So we'll say, as long as, so let's make location to insert, I'm going to start that at I minus 1, because I want to start by looking to the position that's directly to the left of the value I want to insert. Okay, so as long as the location to insert is in bounds, so as long as it's greater than or equal to 0, and as long as the value at the place I'm looking is larger than or equal to the value I want to insert, that means I want to keep looking. So let's think about it again. When do I want to keep searching left? I want to keep searching left if the value that I'm trying to insert is smaller than this thing. So actually, maybe we should phrase it that way. The value to insert is smaller than the location I'm looking at right now. Because if the value I'm trying to insert is smaller than the location I'm looking at right now, I want to look at another location. But I don't want to go so far that I go out of bounds. And so that's what this thing is about. Okay, and so the way I'm going to keep looking is I'm going to just subtract 1 from the thing I'm looking at. Okay, when I'm done, what I'm sure of is that, oh, sorry, the other thing I wanted to do is I want to actually copy. So let's copy value at to its right. Because if I'm looking at a location directly to the left and I discover that I'm not trying to insert anything there, then I want to shift that one up. And so the way I'm going to shift it up is I'm going to say array location to insert +1 equals array location to insert. So I'm taking the value and I'm copying it 1 larger. Okay. So once I'm done, I'm sure that location to insert has gone 1 too far, because this is a test for, like as soon as this test is false, that's the test where I've gone 1 too far. Let's think about how I could explain this better. Yeah, so let's think about when this would be false. This might be false if the value I'm trying to insert is not smaller than the location I'm looking at. And if that's true, then I'd want to copy the value I'm trying to insert 1 larger than that. The other time it might stop is if I've gone out of bounds. If the location to insert is not greater than or equal to 0, which must mean that it's -1. And so if it's -1, I wouldn't want to copy my value into -1. That would go out of bounds. I'd want to copy it into the leftmost position, which is 0, which is location to insert +1. Okay, so there we go. I think that's now done it. Let's run it and see if it works. Okay, that seems to have sorted things. Great. I mentioned that it might not be the most efficient thing. Here's why. It's the same thing that we saw in the bubble sort. If I have sorted everything except the last element also has to be sorted by definition. So I don't need to visit that last one. Wait, is that true? I don't think that's true, actually. Hold on. Let's run it. Yeah, no, so that doesn't make any sense in this case, because this is what I was thinking. So if the last thing is actually the smallest thing in the list, you still need to insert that last thing. So I think we've already done the thing that I've said by starting at 1. Anyway, okay, so that was worthwhile thinking through a little bit. Oh, I think that's the end, right? So that's all that you have to do. I know in the homework I said that I wanted you to modify selection sort a couple of ways, but that I really do want you to try on your own now that you've wrapped your head around kind of the basic implementations. Good luck!